Greedy, hello. Greedy problem solving method is one of the most popular problem solving methods which is discussed in computer algorithms. And greedy problem solving algorithm is one of the specialized and widely used problem solving method. What is greedy? So greedy is any algorithm that follows the problem solving heuristic by making a logically optimal choice at each stage can be very easily handled using greedy method. What happens whenever we are trying to solve a problem, then we'll think that whether this particular problem can be solved in with this particular method or not. So we'll try to apply most of the available problem solving methods, and greedy is one of them. When we go for a greedy, we will be getting a result, best result at that particular situation. So let us think about finding a topper of a particular class. Finding a topper in a class, we will write down marks of all the students, and when we sort, we'll get the best in the descending order at the top. So that is considered as a best at each stage. So when we remove the top person from that particular list, then we'll get a second person as a top. So every stage we always get a best result at that stage is the one of the most important feature of greedy problem solving strategy. In many problems, a greedy strategy does not usually produce an optimal solution because it is not the best. It is best for most of the problems, but every problem cannot be solved using greedy technology, greedy problem solving method. So we have many more methods that can be applicable, which can work better than greedy in some specific problem solvings. So we have some other methods, and that can be easily done using problem solving methods. Some examples of greedy problem solving methods are Prim's minimal spanning tree algorithm, traveling salesman's problem, graph map coloring problem, and there are many more. So these problems can be solved using this greedy method. So we have one of the most popular problem known as activity selection problem. So we'll try to understand how this particular problem can be solved. The activity selection problem has some of the activities which are represented here with the significance or with the icon I, whereas I is equal to 1 2 3 4 5 6 7 8 9 10 11. So we have got 11 activities. Si is the start time and fi is the finish time of every activity. With this particular state, with this particular table, we can understand that the activity 1 starts at a unit time 1 and it finish its execution at a unit time 4, whereas activity 5 will start its execution at a unit time 3 and will end its execution in unit time 8. So the start and finish time of every activity is explained here, written here. So when we want to solve this activity selection problem, then what we have to do, we have to understand that how this particular method can be solved. So we can think in a different way, that is solving a problem with respect to the time. But we have got a unique method for solving this. Once we sort these particular activities with its a finish time first, or with the finish time ascending order, then we will get a proper order with which we will be able to select an activity which is not going to overlap to another activity. If you look at this particular diagram, a graph, then we can very easily understand that many activities are overlapping each other. Then which activity we have to select? So that what we do, we will find out, we'll list out all finishing time of all the activities and arrange them in an ascending order, sort them in an ascending order. Once we do it, then we'll get a very specialized or very easier way to find out the solution. So what we can do is, this particular algorithm explains us many things. The greedy activity selector, it has a start time and a finish time f. Then NA is a empty array in which we will be going to store the activities which are non-parallel, non-overlapping to each other. Let's assume the first activity is stored in array A, resultant array A. I is the first activity, whereas M is the time, start time of every activity from 2 to n. So if the start time of a second activity is greater than the finish time of first activity, then only we will choose that particular activity whose start time is larger than a finish time of first activity, and will store it into an array, the resultant array. Then the start time of the second activity will become most important factor for further selection. So this continues for selecting the activities one after another, and as a solution, as a result, we'll get A1, A4, A8 and A11, these activities as a resultant activities. So A1 has it's a finish time, and then the A4 will have the start time, so that these two activities are non-overlapping. The finish time of this activity A4 is smaller than the start time of the next activity A8, the same as with A8 and A11. This is how we get the resultant solution, resultant non-overlapping activity set as a final solution. Then we have another problem which is very popularly known as a fractional knapsack problem, very widely known and explained for understanding a greedy problem solving method. So we are given n items with their corresponding weights and values. We have a knapsack weight whose weight is W. We have to choose among these n items to put into the knapsack such that the value of a knapsack is a maximum. So now we have a knapsack whose capacity is 50. It's written here whose capacity is 50, and whose weights and their weights and values are defined here. We have items known as, this is the first item, this is first, this is second, and we have a third item. So these three items are available. So the value of this particular item is 60, whereas the weight is 10. The value of this particular second item is 100, whose weight is 20. The value of third item is 120 and the weight is 30. So we have to fill this particular knapsack. We can fill any of these items, but the final result should be maximum. What maximum result we can generate is 240. This is the output. But we have to achieve this particular output, we have to think in which particular method we can store the result. So what we can do is, we can what we can find out the value per unit for this particular item. So for finding out this, what we do is, per unit value will be generated for this particular item, the second item and third item. Once we calculate the value divided by weight, we will get 6, 4, 6, 5 and 4. The 6 for first, then 5 for second and 4 for third. So if we understand that per unit value of first item is 6, per unit value of a second item is 5, and per unit value of third item is 4. So if we arrange this in a descending order, because we are expecting a maximum value that particular item to be stored in the knapsack. So in this regard, we have to store the complete first item whose weight is 10 into the knapsack. Once we do it, we will achieve the 60 value in the knapsack. Then the first item is done, then which is whose weight is 10. Then we will store a second item whose value is 20. So the weight is now 20 in the knapsack. So 20 plus 10 is almost 30. So it's done. So 60 and 100 is stored in the knapsack, and we have achieved 160 value. But third item we cannot put completely into the knapsack, but two-thirds of the item can be kept into the knapsack, and this is what we do for achieving the maximum weight. So 240 will be the maximum weight that we can achieve as a final result into the knapsack. This is how we can solve the fractional knapsack problem using a greedy method. So this is the algorithm that we have to understand for a fractional knapsack. So what we will do is, first is S is empty, which is the final result that we are expecting here. So in this particular final result, we have to evaluate the incremental cost of each element. So what we do, we will store almost all the elements into the in the as incremental order and choose the best. So while S is not a complete feasible solution, while S is not a complete feasible solution, means we have not achieved the final result, then do keep doing it. What to do? Select the element S from E, because this particular items has been already sorted, and we will be choosing the best element which is smallest incremental cost. If it is suitable, then store it into the final array S, final solution. Update the incremental cost of each element by E by S, and we will keep doing it until unless we get the final result as S for a fractional knapsack problem. So this fractional knapsack problem can be achieved for the best output or the best output, minimum best output. Both these conditions, maximum, minimum, can also be achieved using this greedy algorithm for the problems which can be solved using greedy algorithm. So I expect you to implement this fractional knapsack problem for using some programming language. Thank you.